Hi everyone. In this video, we are going to talk about compound interest. So I will say up front, if there is anything you learn from this course at all, if you forget everything else and you only remember this section, this is probably the very possibly at least the most useful thing you can learn in this entire class, the most valuable information you will learn in this course, and that is compound interest. Okay, so let's talk about that. The compound interest formula is as follows. We have A is equal to P times 1 plus R over N to the N times T. Okay? Now it looks messy, but it really isn't that complicated. This is very similar to the formula we just used. There's just a couple other pieces to it. All right, P is a lot like A in our last formula, where we have the principal deposit. This is the initial amount that you invest, or if you're loaning, if you're taking out a loan, this is the principal amount that the amount you're given at the initial part of the loan. Okay, R is your annual interest rate. N is the number of times the interest is compounded per year. Okay, and T is the number of years. Okay, so all you really do is you just take this information that's given to you in the problem and plug it into our formula here. So this will be a formula definitely that you want to memorize for the final. Because I can almost certainly guess that one of these will be on the final or something like it will be. So this is one to memorize if you can. All right, so let's take a look at a couple examples. The first one I want to look at is a loan example, okay? So let's suppose that $2,000 is loaned. So you go to the bank, you take out a loan for $2,000, and it's loaned at a rate of 15% interest. It's compounded monthly. All right, so assuming no payments are made, find the amount owed after 9 years. So you take out this loan, it's at 15%, and you don't make any payments on it. What is it that you will owe 9 years from now? All right, so let's find each of our values. Here we want to find P. P is our first value. That's our principal amount. Our principal in this case, since we're taking a loan, it's our principal amount. So we will say the from this problem it looks like $2,000 is our initial amount. So P equals $2,000. Okay. R is our annual interest rate. All right, so it's loaned at a rate of 15%. So anytime you see something worded that way, where you have a loan is at 15% or an investment is at 15% or whatever, that is your annual interest rate. So here we have annual interest rate. Okay. Alrighty. So, but we also want to express this as a decimal. Okay. So let's go ahead and do that. So we can do it'd be 15 divided by 100, and that'll give us 0.15. All right, so just like in the last one, we want to make sure this is expressed as a decimal and not just as a whole number. If you have a whole number, this is going to be a crazy calculation here. So make sure you write your interest rate as a decimal instead of just as the percentage. Okay. N is the number of times per year it is compounded. Okay. So here um, it says it's compounded monthly. So it's compounded monthly. So what that means is that there are 12 times in a year. There's 12 months in a year. Therefore, our N is going to be equal to 12. Okay. So it's compounded 12 times per year. And T is the number of years. And we said T, number of years, was 9. Okay, so let's take all of this information and let's plug it into this formula. So the amount that we're going to owe after 9 years, A, is going to be equal to P, which we said was $2,000, times 1 plus R divided by N. So we'll have 0.15 divided by 12, okay? Times or to the N times T. So it'd be to the 12 times 9. Okay, so let's see what we get when we plug this into a calculator. All right, so we'll do 1 plus 0.15 divided by 12. Parentheses are your friend, by the way, when you're using these when you're doing this on a calculator. So keep that in mind. Okay. All right. So if you plug this into a calculator, what you're going to end up with for your final answer is a grand total of $7,650 and 56 cents. Okay, so this is the lesson to learn here when it comes to loans. All right. So if you take out a loan, the first thing you want to look at is the interest rate. If the interest rate is high, it's gonna grow very quickly. Okay, that is a very important part of this. Okay, um, if the interest rate is low, then that's obviously better if you're taking out a loan. And then also the importance of making payments. If you didn't make any payments on a loan that you took out and you don't do anything with it for 9 years, say a student loan, for example, you're all in college, so if any of you have taken out student loans, if you don't make any payments on it for 9 years, hopefully they're not at 15%. But if you haven't made any payments on it for 9 years, if you had an initial loan of $2,000, you would now owe $7,650.56. So that is why it is important to A, make payments, and B, make sure you check the interest rates on loans that you're getting. Okay, and maybe pull out one of these formulas here that we're using before you decide to take out a loan for a car or something like that, right? Yeah, so I'll stop lecturing about the I'm not a financial expert. It's not my wheelhouse, but I do know a little bit of math, and yeah, math can be your friend in these situations. All right, so let's take maybe a let's end this on a happier note. Let's suppose that you want to invest $2,000 at a rate of 3.3% interest, compounded annually. Okay, let's assume we don't take anything out, so no withdrawals are made, and we want to find the amount after 8 years. Okay, so let's find out what our P, A, or it's our P, R, and T are. So we're trying to find A, which is the amount. So P, our principal deposit, is in this case also $2,000. Okay. All right. So let's take a look at our R value. Our rate we said was a rate of 3.3%. And if we do 3.3 divided by 100, we'll get 0.033. Okay. And then we have N, that's the number of times per year it's compounded. And here we have it's compounded quarterly. Quarterly means that you do it 4 times a year. So each quarter you would compound it. So if it's each quarter, that means there's 4 times per year. All right. And then T is the number of years, and we said that was 8 years. Okay. So we would go ahead and solve this problem. So A is equal to P, which we said was $2,000, times 1 plus, we said it was R over N. So in this case, it'll be 0.033 over 4. And this is going to be to the N times T. So we'll have to the 4 times 8. All right, so if we plug that into a calculator, we will get, should be 2,601.44. Okay, so if you just left it alone for 8 years, um, that is how much you would have after 8 years. Now this would work similar if this would work similarly if this were a loan, right? This same principle. Let's pretend for a second it was a $2,000 loan, and it was an interest rate that compounded quarterly at 3.3% that you owed. Assuming you made no payments, this is how much you would owe after that time. So this is why interest rates are so important. So if you have a lower interest rate, you're going to owe a lot less than if you have a higher one. Okay. So again, hopefully this is of some help to you, and maybe at some point in your life you will get a little bit of use out of this. But just real quickly, I wanted to show you a quick chart with this of likely periods of time to pop up in these homework problems. So we call this the term here. So if you have interest that's compounded annually, your end value is going to be one. So it's gonna compound one time per year. If it's compounded semi-annually, the phrase semi-annually means it's compounded twice per year. So that means your end value is going to be two. We just talked about quarterly, so be 4 times a year, typically once every 3 months, and that'll be four. Your end value will be four. Monthly means each month it's compounded, and that'll be at 12. So there's 12 months in a year, and weekly will be 52 because there's 52 weeks in a year. Okay, so if you encounter any of those, these are the numbers that you're going to use for those problems.